Orthogonal frequency division multiplexing is not really a spread spectrum technology in the sense that FHSS and DSS are. However, it's usually lumped in with spread spectrum technologies since it does have to do with an array of frequencies, but it's not really done for jamming purposes or for anti-hacking purposes. It's done for multiplexing purposes. In other words, to get more data across a wire. So what is orthogonal frequency division multiplexing? A little bit hard to explain, but I'll do my best. Again, we think of a frequency, say 5.0 gigahertz, not as a single frequency of 5.0 gigahertz, but of an array of frequencies around it. So we have channels, these little subcarriers, these little subchannels of small groups of frequencies that are actually used. Now, if I carefully select those frequencies, which is what we do in Ofdm, I very carefully select those frequencies so that they converge at the same point. And you can see that here. Here are different frequency sine waves. The blue, the light blue one here is obviously very different from this dark red one. But they all come together at the same time, and they all hit 0 at the same point. I really can't think of a great way to describe how that works. When I think of music, for example, I think of a piano key. If I hit that piano key, I'm not just hearing that frequency. I'm hearing harmonics of that frequency at the same time. I'm hearing octave versions of it and fifths and so on, so that I'm hearing a whole range of them. That's one of the things that gives the piano its unique sound, that makes it different from the sound of a trumpet or the sound of an accordion. And we call that the timbre, the sound, the overall sound. Well, that's kind of what's going on here. We have different harmonics that manage to all come together at the same time. So what happens when you do that? Well, what happens when you combine two things that come together at the same time? Again, I'm going to refer to music. If you think about the big band era, and there was a very big song back in the big band era called, what was it called? In the Mood. It took me a little while to think of it. And if you remember that song, okay, think what's going on in that song. I've got three notes. Just three notes. But I've got 4 beats per measure. So the 3 and the 4 combine, and what happens is that the emphasis on those 3 notes keeps changing. Da 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 da. So it keeps moving, and you hear this kind of movement across those notes. Da 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 da, like that. And so that's kind of what's going on here. The intervals keep melding together. I know it's a hard concept, but what ultimately happens then is you get this. If I combine this with amplitude keying, then I can put these different frequencies. See, they're each at different frequency, but I can send 3 different signals at the same time, and they don't interfere with each other because of this orthogonal way that they're melded together.